Recording. Ladies and gentlemen, welcome to this session of Grade 11 Physical Sciences. I am Mr. Nambani from the Nambani Academy. The thinking will be, we want to give you a head start. By head start, we mean we usually try to do topics that are not necessarily yet done in school, such that by the time you do them in school, then it will be a form of revision to you. So when I sat down, I actually chose this topic only because when we look into the planning documents, this is now the teaching plan of grade 11, term 3. We can easily see that it is going to take about 4 weeks more or less to complete this particular chapter. So what happens is we tend to rush it, and when we tend to rush it, we lose important concepts. It feeds from grade 10, so we'll start with the basics and eventually get into the critical things of grade 11. But the only new thing in grade 11 will be the introduction of a limiting reactant. So what I'm going to do will seem and look like it's something that you have seen before. But Your Excellency, Mr. Nyokong, the thinking is we need to build a solid foundation. We need to ensure that whatever we do, we actually understand each and every single basic concept. So let's go back to the topic itself, or the title of the topic. The title of the topic is called Quantitative Aspects of Chemical Change. What do we mean with quantitative? We are interested in what we call a measure, or basically quantity. So whatever we do, we are going to try and have a certain form of measure, have a certain form of quantity. But how are we going to do this? This will only be through now what we call chemical change. What will be chemical change in this instance? Chemical change will be now either through the reactions or either through the principles that we are going to develop. So the topic itself, it's about the measure of substance, the measure of quantities, and the measure of now everything that relates to chemical change. So this will be now given to us in a sense of form of reactions. That is going to be very, very important to us. Now, like I said, we don't only just teach for the sake of teaching. We teach for the purpose of ensuring that when we get into the exam, we can actually plan and be able to answer the questions as exposed or brought forward to us. So these are just now bullets that one must ensure that by the end of the lesson, as now lesson outcomes, each and every one of us is able to understand what is a mole, to understand the Avogadro number, to understand the molar mass. But what does this say to me? This says to me, I need the following important documents. The very first document is a periodic table. So periodic table, remember, it will be given in an exam. So if periodic table is given in an exam, I must always have a periodic table also. Secondly, I must have now an exam guideline. Why do I need an exam guideline? I need an exam guideline to assist me with now the definitions of the chemistry. So we agree that the very first one that I need to be looking for, or that I must always have, it is a periodic table. After the periodic table, I need now the exam guideline. The exam guideline will be important in giving me now the definitions. Remember, definitions basically explains now the concepts thereof. When this is done in terms of definitions, what I need to do is to check now the relative definition against what is given to me in a form of the teaching plan. So we are going to try and address all these bullets in this particular session. So without wasting any time, ladies and gentlemen, just ensure you have a periodic table closer to you. We'll start moving from the basics of grade 10 and now to grade 11 and feed you with a strategy maybe of now grade 12, because this topic is very, very important as it overlaps from grade 10 to grade 12. So let's get into the basic concept. Let's not waste time on this particular mind map, because it's what is explaining how we are going to go about calculations and everything. Let's start. The very first bullet says we must define what is a mole. In grade 10, we defined a mole as the quantity of matter that has the same number of particles, atoms, or molecules, or ions as there are in 12 grams of carbon-12. So what do I need to know from this? Very important. One must know the definition thereof. So definition of what is a mole. So a mole is defined as the quantity of matter that has the same number of particles, atoms, molecules, or ions. So that will be now influenced by what is it that I am working with. Am I working with atoms? Am I working with molecules? Or am I working with ions? So mole can basically represent any other number of what? Atoms, molecules, or ions. As there are 12 grams of carbon-12. What does this mean? This means now if I have 1 mole, the mass of 1 mole of an element is equal to its atomic mass in grams. So when I look into my periodic table and I check, if I have 1 mole of sodium, it will have 23 grams of mass. Why? I want us now to introduce the concept of molar mass. The concept of molar mass for sodium, when we look into the periodic table, it's now 23 grams per mole. So it means now for every 1 mole of sodium, I have now what? 23 grams of mass. So it basically says what we see on the periodic table as the molar mass. It actually represents 1 mole of a substance or an element. in a sense that that amount of molar mass is actually the mass only if I have one mole. What does this mean? It means now if I have 1 mole of Ag, it will basically represent 108 grams, which is the mass of Ag in the periodic table. Now, when I have 1 mole of H2SO4, now let's check here. H2SO4, it is now a compound. And if it is a compound, it basically says we will need now to calculate the total molar mass of that particular compound. But 1 mole will represent now the actual mass in grams of what? Of the compound, or even now the element. So I am going to pause, give you your 30 seconds for you to digest the concept now of mole. What do we understand by 1 mole of a substance? 1 mole of a substance basically means is equal to its atomic mass in grams. But a correct definition of what is a mole will be now a mole is the quantity of matter that has now the same number of particles. So the 30 seconds now is for you to digest everything on this slide. At the very same time, if you have a question, you raise your hand, then you ask a question relating to the mole concept. Thank you very much, ladies and gentlemen. I don't see any hands, comments in the chat. So it basically says we actually understand the mole concept. What is important is the definition and the meaning and the application of what a mole represents. Moving forward, it brings now the concept of molar mass. I'm going to differentiate between a relative formula mass as well as the molar mass. So molar mass, we say, let's look into the molar mass of sodium chloride. And the molar mass is defined as the mass of 1 mole of a substance. So the molar mass, the molar mass of sodium chloride will be, from the periodic table, will be 23 plus the 35,5. So let me just get this pen going. So for us to calculate the molar mass, will be easy to say the molar mass of sodium chloride will just be 23 plus 35,5, which will give us something like, quick calculator, it's 23 plus 35,5, which will give us something like 58,5. So this will give us 58,5. Let's leave it there. And we do the same now with AR, which is relative formula mass, is equals to 23 plus 35,5, which is just 58,5. But what is the difference between the two? The relative formula mass is defined as the relative formula mass of ionic substance is the mass of one formula unit on scale where carbon-12 has a mass of 12 units. Basically, this is the application of the mole concept. And molar mass, it says the mass of 1 mole of a substance. Now, if you check, there is one thing that is different between the two. And that one thing is what we call the SI unit. So once we assign the SI unit, grams per mole, then we are referring to molar mass. But if we do not have a unit like in this instance, it means we are only referring to relative formula mass. So when we want now to calculate the molar mass, we need to associate that molar mass with the SI unit. If we associate it with the SI unit, it becomes easy for one to actually say, I am working with the molar mass. What is the molar mass? It's the mass of 1 mole of a substance. Any questions relating to this? If there are no questions, let me maybe quickly give you your 30 seconds. We have explained a different concept, the concept now of molar mass. So molar mass is the mass of 1 mole of a substance, and it is measured in grams per unit. Sorry, grams per mole. So it basically says, whatever I do, if the examiner at a certain instance wants me to calculate the molar mass, it will be possible for me to use the molar mass and now to identify the substance that is now in the periodic table. So this here will assist me to say substance in the periodic table. That will now assist us to identify substances in the periodic table. Now let me give you your 30 seconds for you to digest. Ladies and gentlemen, thank you very much. Let's move now to this particular slide. I am not going to waste a lot of time, but we will just check how we go about ensuring that we calculate the molecular mass and the relative formula mass. The very first one says, what is the atomic mass of Mg as an element? Very easy. We just go to the periodic table and we get that it is 24 grams per mole. What is the molecular mass of H2O? Also very, very easy. This is grade 10 work. You should not be worried about it, but we are now emphasizing on the basic principles. Furthermore, what is the formula mass of sodium chloride? We just did that and we found that our final answer is something like 58.5 grams. So one can just easily write 58.5 grams per mole. You just refer to the previous slide when you get the E notes. Then the difference between the two is just when we talk relative atomic mass, we do not consider the SI units. That is the reason why our answers are like that. But now I'm going to give you a minute or so for you to calculate now the relative formula mass for MgSO4. MgSO4, that will be now our activity number 1. What you do, you just send me just an answer that you got, you just type it in and we will confirm with what I have. Just a minute for you to do MgSO4. Thank you very much, ladies and gentlemen. I'm waiting for the answers. And thank you, received. Thank you, received. 2 more, please. 2 more. Thank you, received. Thank you, received. Ladies and gentlemen, received. Thank you very much. Thank you very much. Let's see if we are all on the right track. Now, Mg is 24 plus now S is something like 32 plus now 4 multiplied by 16. That will give you now 120. So that is not a problem at all. We actually got it right. Let's now 4 multiplied by 16. 4 multiplied by 16 and the final answer is 20. Let me just do it nicely. Multiply by 16 and this will give us now 20. Very good. I am happy with that. So it basically says we are happy with now the important bullets here. The very first one, describe a mole, define a mole, define molar mass, calculate the mass of a substance for the given formula. So we are happy with that. Now, when we are happy with that, it basically says what must be done now immediately after that. Ladies and gentlemen, this brings us now to relative atomic mass. Relative atomic mass is for grade 10. But remember, like I said, this topic now moves from grade 10 to grade 12. So everything and anything of grade 10 will be now assessed, will be a part of the questions of the exam. So what do we need to do? We need just to ensure that everything that we do, we basically explain the concepts in details for the purpose of one now knowing exactly what is it that needs to be done. Now let's move. For the relative atomic mass, this occurs when we have isotopes. The relative atomic mass of an element is weighted average of the masses of its isotopes. So the one will ask, what is now an isotope? What is now an isotope? So from the isotope itself, we need now to give a definition thereof. What is now an isotope? So if one can explain what is an isotope, everything will be coming easy in a sense that we understand what are we working with. So it is important now to say an isotope is defined as, let me just accept Loazi. So now maybe one question should be, what is an isotope? So kindly now just type your answer for me for us to be able to know that, or check what is it that you know relating to the isotope. That will be given now a minute for one to type in your answer of what do you know of an isotope. Ladies and gentlemen, thank you very much. Let's start with now a definition. Thank you for all the answers received. A definition of an isotope is atoms of the same element, with the same atomic number, but different mass number. Different mass number. Now, this tells us that for us to actually know the actual relative atomic mass, we need now to have a weighted average of the mass. What is the weighted average? An example here says element X is found naturally in 3 forms, namely 30% as 29x, 22% as 30x, and then 48% as 31x. So what is it that is happening here? X is basically the same element, but what is changing here is the atomic mass number. So hence we have 29, 30, and 31. So basically these are isotopes of each other. But now we want to know what is the relative atomic mass of element X. I am going to change this question and say identify X. And how are we going to identify X? We are going to use the periodic table for that. So to calculate the relative atomic mass, one must say AR, or relative atomic mass, or average atomic mass, is basically 30 multiplied by 29 plus now 22 multiplied by 30 plus now 48 multiplied by 31, but all this, they must sum up now to 100%. So this is now one of the important calculations that one must look into. So this is going to give us something like 31 grams per mole. So when it gives us 31 grams per mole, the question will be, the question says identify X. So we want to know what is X in this instance. What must we use? We must use that periodic table and go and check now for the molar mass of 31. So the molar mass of 31 is P for phosphorus. So we are actually using this method of isotopes, this method of relative atomic mass, to actually explain now what it means when we say we are calculating the weighted average of the mass. So it is the percent multiplied by the atomic mass. It is the percent multiplied by the atomic mass plus the percentage multiplied by atomic mass. The only key thing that one must look for is that your total percent must be equals to 100%. So already we are trying now to introduce basic calculations that are going to assist us in identifying elements in the periodic table. So when you do this calculation, your answer relates now to phosphorus, which will give you now 31 grams per mole. So we are using this in order for us to eventually identify the element X. So this is one now of the basic concepts that I want you now to grasp and understand. Is this from grade 10? Yes, I understand, but it's building towards the bigger things that we are going to do in terms of calculations of grade 11 stoichiometric calculations. So ladies and gentlemen, with that being said, let me just ensure that you understand and give you your 30 seconds to digest everything. Feel free to ask your questions and be ready. I'm going to give you now a sort of an exercise of this nature and be able now to see where we are in terms of that. We are building the basics towards now more complex stoichiometric calculations of grade 11. Questions, please. Let me basically maybe quickly check. Lesedi Katadi, inputs, please.
So far, sir, I'm understanding the work.
Thank you very much. Neo Mudiani.
Sir, I understand the work so far.
Thank you very much, Your Excellency, Mr. Nyakallo.
No, sir, I understand the work.
Thank you very much, ladies and gentlemen. Let's try now and do now this particular activity very quick. It is just define the term isotope. You can skip that. You have given me your definitions. What I want us to do, and quickly, it's now write down the name of element Q. That will be done now in the next 4 minutes. Kindly send your answers now to me. Ladies and gentlemen, thank you very much for your answers. Mostly received. Thank you, thank you, thank you. Let's check the approach. It's an easy one. Thank you for your answers. The definition of an isotope that we have done, no problem. Let's quickly go to 6.2. Now at 6.2, it will be now average weighted mass is just now 20 multiplied by 90,92 plus now 21 multiplied by 0,26 plus now 22 multiplied by 8,82 divided now by 100. This will give you something like 20,1 20,2 grams per mole. SI unit, very, very, very important, ladies and gentlemen. Let's not forget now the SI unit. Then I go to my periodic table of elements. Then I find that now Q is actually neon or just NE. And for doing such, I will be given at least a maximum of 4 marks. So it was an easy one, but let's just know now use the periodic table accordingly. Luandle, remember here we get now the atomic mass. We get the molar mass. So the 40 that you are referring to or the 20 that you are referring to, check the periodic table. It says now we are now looking into the atomic mass, not the atomic number. So this here refers to the atomic mass or the molar mass, not the atomic number. Hence, I assigned now the SI unit to this whole calculation. Is one of the key critical concepts that one has to look into before we now move into more complex things. Now that we are happy in terms of using and calculating the molar mass as well as the relative atomic mass for the purpose of identifying different elements in the periodic table. Ladies and gentlemen, it says we can now move to the Avogadro number as well as the Avogadro law. What does this say to me? It says when I have to explain the Avogadro number as well as the Avogadro law, it says a mole is a quantity of matter that contains Avogadro number of formula units. What does this say? It basically says 1 mole of a substance contains now 6,02 multiplied by 10 to the power 23 elementary units. What are these elementary units as well as particles? Ladies and gentlemen, this can mean atoms, this can mean molecules, and this can basically mean ions. So whenever I'm expected to calculate the number of atoms, I am going to use the Avogadro number. Whenever I am expected to calculate the number of molecules, I am going to use an Avogadro number. So 1 mole represents 6,02 multiplied by 10 to power 23. If that 1 mole, it's 1 mole of sodium, which is an element, it will basically mean it is equals to 6,02 multiplied by 10 to power 23 atoms. Hence, when we look into this diagram here, 1 mole of iron, from the definition of 1 mole, it will have now 56 grams as mass, but it will have 1 multiplied by, or 6,02 multiplied by 23 atoms. So basically 1 mole represents now the constant of the Avogadro, which is now what? The Avogadro number. If I am working with molecule, which is now 18 grams of water, it means now I am going to have 6,02 multiplied by 10 to power 23 molecules of what? Of H2, H2O. So in every 1 mole, ladies and gentlemen, I am going to have 6,02 multiplied by 10 to power 23. But it will only start changing when now I change the number of moles. So it will be the same now with formula units. 1 mole of calcium chloride, which is 58.5 grams, from the understanding of mole concept and the molar mass. That will represent 6,02 multiplied by 10 to power 23 formula units. We further derive the equation for calculating the number of moles as well as calculating the number of particles. What does this say to me? It says these 2 equations that you see on your screen, the one says N is equals to M over M. The other one says N is equals to number of particles. But this we usually refer to as N is equals to N over NA. So where number of particles, I repeat, can represent atoms, can represent molecules, can also represent your ions. So we will need to be on the lookout to say what is it that the examiner is actually referring to. If the examiner is referring to atoms, I will still use the same equation. If the examiner is referring to molecules, I will still be using now the same equation. But furthermore, it says for me to use this equation, I need to get the number of moles. So the number of moles, it is the basic principle, a basic concept of me building towards now proper calculations of stoichiometric calculations. So what needs to be done is for me to ensure that I can calculate the number of moles for each and every different situation given to me. So when I check here, it's number of moles. I'm going to call now this one equation number 1. This one, I'm going to call it equation number 2. Ladies and gentlemen, why? Because these two equations, I will now be at some certain stage, combine the two to build a complex stoichiometric calculation. Ladies and gentlemen, this is just a basic table that explains how to get the number of moles. So when we go to the periodic table and look for carbon, remember we are referring to 1 mole of a substance. So if I look into carbon for 1 mole, it's easy now from the multiple choice questions to say, what does 1 mole of carbon represent in terms of mass? It will represent 12 grams. How many atoms or particles do we have? It is an atom, but now it will be 1 multiplied by the Avogadro number, which will just give us 6,02 multiplied by 10 to power 23. So it will change until we get to molecules, but we get the same answer still. But now there's something that is changing here. What is it that is changing? When we have the ions, it is starting to change. Why is it changing? Because sodium chloride dissociates to form sodium plus Cl minus. Now, where do we get this important information? This important information comes also from grade 10, where now we talk of ions, molecules, and atoms. So how many ions do I have? This is now an atom, Na plus, Cl minus is also an atom. So how an ion, how many ions do I have in this regard? I have 2. That is the reason why I multiply now thereby by 2, because I have 1. This represents now 2 ions. So with that being said, it basically says I will have to check, especially when I work with ions, what is it that I have? The dissociation of the compound into its ions is very, very important. That's the reason why I said you will have to go back and basically check into your grade 10 notes in terms of the ions themselves. So ladies and gentlemen, with that being said, it means I must give you now your 30 seconds for you to digest, and we will move into a different concept. Thank you very much. With that being said, I don't see hands, I don't see comments. So it basically says we can move now to this particular problem here. I will do number 1, and number 2, you will quickly do number 1. We are just going to try and save time, but we cannot take things for granted and assume that you are able to perform these calculations. Ladies and gentlemen, it says calculate the mass of 0.5 mole of H2SO4. Where do I start? I am given the number of moles. The examiner is asking for mass. Then I need to have the molar mass. So the first thing to do is to calculate the molar mass of H2SO4. Ladies and gentlemen, I must show all my workings to the examiner or the person who's going now to mark my script. So this will be 2 multiplied by 1 plus now sulfur periodic table, very, very important, 32 plus now 4 multiplied by 16. This is something like 98 grams per mole. The formula, ladies and gentlemen, I must write it as it is from the formula sheet. That is now N is equals to M over M. This will be now 0.5. And then M is what the examiner is asking, divided now by 98. Then I'm going to say mass of H2SO4 is just equals to calculator 98 multiplied by 0.5. This will give me something like 49 grams. Very, very important and very easy to do. Ladies and gentlemen, in the next 3 minutes, let's quickly do number 3. It says the mass of 2 mole of ionic compound is 80 grams. Calculate the formula mass of this particular compound. Just in the next 3 minutes. Ladies and gentlemen, thank you very much for your answers. Let's quickly look into it. It was an easy one. You just say number of moles is equals to mass over molar mass. Your substitution is 2, and the mass is given as 80. We want the atomic mass. So the atomic mass is equals to something like 80 divided by 20. This gives us now 40. Ladies and gentlemen, the SI unit is very, very important. Why? Because the SI unit tells us now the measure or the quantity that we are referring to. That is the key critical now information that you cannot be given a mark provided you assign the correct SI unit. So this is now grams per mole. Can I use my periodic table maybe to check the compound? I am not sure. It can be anything, but it looks like the compound here that they are referring to is argon. It was not asked, I'm just adding it for the purpose of thinking and remembering. Maybe the question tomorrow will come and basically just say, identify the compound. Then the compound will be argon for that matter. And how did we go about it? We used now our periodic table. Ladies and gentlemen, I am going now to do this one for you. It basically says calculate the number of atoms in 12 grams of carbon. Ladies and gentlemen, if I want to calculate the number of atoms, there's one thing that I need now to do. The very first thing is to get the number of moles. The number of moles of what? The number of moles of carbon. Because the equation I have for me to calculate the number of atoms, it says N is equals to N, which is the number of particles, divided by the Avogadro number. So I need to calculate the number of moles of carbon. And this will just be 1,2 divided by 12. And when I take my calculator, it's 1,2 divided by 12. This will give me something like 0,1 mole. The SI unit, very, very important. Then N is just equals to N over Na, which is just 0,1 sorry, 0,1 N divided by 6,02 multiplied by 10 to power 23. 6,02 multiplied by 10 to power 23. Then I take the calculator, multiply by 6,02 exponent 23, and this gives me something like number of particles is equals to 6,02 multiplied by 10 to power 22 atoms. SI unit, very, very important, because remember, we are working with now measure of what, ladies and gentlemen? Measure of different quantities. Ladies and gentlemen, with that being said, let's now try number 5 in the next 2 minutes, or I will even give you 3 minutes for that. Ladies and gentlemen, thank you very much for your answers. Let's quickly look into it. The catch here, ladies and gentlemen, is just that iodine exists as a diatomic, as I2. So the molar mass of iodine is just 127 plus 127. This will give us, let me quickly take a calculator. 127 multiplied by 2 will give us 254 grams per mole. Then the number of moles of iodine 2 will just be mass over molar mass. This will be now 254 divided by 254. This will just give us 1 mole. It is important, ladies and gentlemen, to ensure that you write now the SI you need. Then N is equals to of iodine is equals to N over Na. This will just be now 1 N over 6,02 multiplied by 10 to power 23. Then the number of particles of iodine will just be 6,02 multiplied by 10 to power 23 atoms. Very, very important, ladies and gentlemen. Very, very, very important. Ladies and gentlemen, with that being said, let's basically check. The time is now 19:26. Thank you very much for all the hard work you've put in. Tomorrow we will start now with molar gas volume and we build towards that. So what is critical today was the use now of this first equation and the use of the second equation that relates now to the number of moles as well as the use of the Avogadro number. But we could not just jump into grade 11 work without ensuring that we have a solid understanding and we have a solid way of how we approach this. Because already some of you made a mistake for iodine. So that mistake or these mistakes are mistakes that we are trying now to do what? To ensure that we eliminate before we get into more complex stuff. Ladies and gentlemen, let me first start with Lesedi. Reflections of today's lesson, please.
So today's lesson was a good revision of grade 10 work because I did not remember most of it. So it was a good refresher today and I learned a lot. So.
Thank you very much. Bonolo Matosa.
So I had the same feelings as Lesedi. It was a good refresher of the mind. And yeah, I can't wait for tomorrow.
Thank you very much. Because remember, we are doing basics with the intention of us reaching or doing all these concepts. Like I will say, the very first one was define the term mole. The second was define the term mole, describe the Avogadro number as well as the molar mass, calculate molar mass of a substance for the given formula. State now Avogadro law. It looks like it's the work of grade 10, but we are actually doing the work of grade 11, but with more depth, with more understanding. Hence, I said tomorrow we'll be looking into know the molar gas volume VM and do calculations using N is equals to M over M, N is equals to V over M, and N number of particles over NA. So these two have been done already. So we are just now adding and building towards the work of week 3 and week 4. So by the end of this week, all the topics of week 2, 3, and 4 will have been done and completed. But the pace that we go into is us developing that we have a solid foundation. So it might look like it's revision, yes, but it's more of grade 10 work that we need now to solidify the foundation. Now, Mr. Nyoko, His Excellency, inputs, please.
So I think today was a good day. I feel like the revision of last year's work will help us a lot in dealing with grade 11 work. Thank you, sir.
Thank you very much. Baanetse Mokgeseng. Her mic is still
So
not okay.
Today's session was pretty good.
Thank you very much. Lesedi Katadi, we are done with you. Lwandle.
So no, it was a good lesson, especially the most of like I've never really enjoyed like heading into these like I think it's the topic is quantitative aspects of whatnot, but I think like I suspect that now with like a better understanding, I'll enjoy it more.
Thank you very much. Lastly, Neo Mudiana, it is your first time here. Your reflections and your experience of your first lesson on the Nambani Academy platform.
So you explained everything really well, and today's lesson was very fruitful in solidifying my foundation of the quantitative aspects of chemical change.
Thank you very much. Ladies and gentlemen, from me to you, thank you very much. Let's meet tomorrow at exactly 17:55. So that we can start at exactly 6 o'clock. From me to you, thank you very much and have a lovely evening. Remember, the e-notes will be sent to you immediately after this session. Thank you very much and have a lovely day.
Thank you, sir.
Bye, sir.
Good night, sir.
Bye, sir. You too.
Bye, sir.